guys are cracking me up.
So we're going to talk about the geometric definition of a hyperbola, how it's created, why it's created, etc. And then we'll get into the graphs and the equations. So geometric definition, set of all points in the plane, the difference whose distance is from the two fixed points, the foci, is constant. So of course, if you take your distances and subtract them, you would get the same thing if I pick a different point. If I really did not write that line. If you pick this point and calculate to the focus, to this focus, subtract them, you will always get the same answer. That is the technical geometric definition of a hyperbola, for whatever it's worth to you. Now, this looks very, very similar to ellipses. The slide on ellipses, obviously a few subtle differences that kicks it into a hyperbola. First thing, subtraction. Yes. Plus for ellipses, subtraction makes it a hyperbola. The other thing to notice too, for ellipses, because you're adding, it's always x squared plus y squared, always. Okay, the denominators change, who cares, whatever. Hyperbolas, it matters which variable comes first. And to me, this is kind of common sense. If x comes first, it opens left and right or horizontally. If y comes first, vertically. They open up and down. So make sure also that you are super conscientious looking at that first little variable. Okay, we have ellipses, we have what we call the major axis. For hyperbolas, we call it the transverse axis. So that is the length between, of course, the two vertices. And I kind of think about hyperbola almost looks like a double parabola. So your vertices, of course, kind of like the vertex on each parabola. So on this guy, here is your transverse axis. Now, we're also going to have asymptote lines. We've seen those before. Asymptotes, remember, lines we get close to, we never cross or touch them. So, easy to do our asymptotes. Again, I'm not going to stand up here like, oh my gosh, is it B over A or A over B? Well, easy. Slope of a line. We all can count slope of a line. It's rise over run. That's really what I'm going to look at for my asymptotes. I'm like, oh, up and over. Rise over run. That's easy enough. Okay, other difference to point out from an ellipse. Ellipse, the foci equation has minus, hyperbola, plus. So I always just kind of remember that as the signs go opposite, meaning a hyperbola equation standard form has subtraction in it, so its foci is plus. Ellipse has plus in it, so its foci is minus. So it's always kind of that pair, you have the positive, negative. Just depends on what figure and what you start with. All right, let's draw some and get into it here. So flip it. So here's just kind of the rough how to draw it. So first thing I'm going to draw is what's called the central box. Sounds fancy, it really isn't. You really mark that out the same way you would in a ellipse. I'm going to count my A, my B, horizontal, vertical, kind of the same thing. Oh, my drawing skills. I'm going to draw the asymptotes then. Those, notice, are going to be diagonal lines that go through the central box. I'm going to get the vertices on there. I'm going to sketch it. Okay, first off though, just you need to, this one is not in standard form. Just like ellipse, not a big deal though. It has to be set equal to 1. So let's divide by 144. You might need your calculator for that. Okay. So, of course, 9 goes into 144 16 times. Of course. 9 times. We all knew that. Now, first off, I'm ready to start marking it out, okay? So, just like you do your ellipses, 16 under x, I square root that, it's 4, under x, left 4, right 4. Remember, our center is at 0, 0 still. So, left 4, right 4. 9 is under y. I square root 9. Square root of 9, 3. Under y. Up 3, down 3. Don't draw an oval. Now, if it said plus and was an ellipse, we'd draw the oval, bing, bang, boom, we'd be done. But it's not. It's not. Hyperbola. So I'm going to draw the central box. So I'm going to draw a little dash box around these 4 points. That is the central box. Now, once you have that, the next thing I'm going to draw are the asymptotes, because that's going to dictate how wide or narrow my hyperbola is. So for your asymptotes, super easy, from the center to each corner. And I'm going to draw those dash. I'm going to try to draw them straight, but well, you know my drawing skills. I'm ready to draw. Now, how I determine whether it's horizontal or vertical, I look at which variable comes first. We have x coming first, so it opens left and right. So on my central box, I'm going to start over here at the right point on it, which is at 4, 0, and I'm going to draw close to the asymptotes. I'm going to try to not cross or touch. I'm going to go ahead and list that vertex point for that one. That one's 4, 0, 4, 0. And then I'm taking the left point over here, negative 4, 0, close to my asymptote. I don't cross or touch. I should have put a longer blank on there. I guess I should combo a plus or minus next time. Okay, I'm going to answer obviously all of this stuff. I'm going to go ahead, I'm going to do a little out of order. Length of the transverse axis. That is the one, you don't have to draw this, I'm just highlighting it for you, that connects your vertices. What's the total width of our transverse axis? 8, you went 4 left, 4 right. Okay. And again, you don't have to highlight it in red like I did. I just did it for this first example for you. Now we do need to do our foci, or put our foci on here also. So that's always the c² equation. Jot it underneath here. And if you're like, you're on your test or whatever, you're like, oh my gosh, is it plus or minus? Well, hyperbola in the form is minus, so my foci is plus. Since it's plus, does it matter if I do 16 plus 9 or 9 plus 16? No, we're adding. Who cares? So I don't stand up here and be like, oh my gosh, is it a squared plus b squared or b squared plus 8? Who cares? You're adding, okay? 25, we end up with 5. I'm going to plot those two. Now, just like your parabolas, the foci are inside the hyperbola. So I'm going to go 5 right. I'm just going to, you don't have to label F for foci, I'm just labeling it for our first problem, and 5 left. And I'm going to write those ordered pairs down, plus or minus 5, 0. Okay, last thing I'm going to mark out, or put on here, are asymptote equations. Now these are super easy, slope-intercept form. So I'm looking at this diagonal line. The y-intercept is 0. They're all 0 today. We're all centered at the origin. My slope, I'm just going to count, up 3 over 4. So that's the positive 3/4 line. This has a negative 3/4 slope. So I'm just going to put plus or minus 3/4. And then x, of course. I'm not putting plus 0 for the b. Elliot.
How do you know where to draw the hyperbola curves?
Why it's horizontal?
Yeah.
Remember that was at the very beginning when we looked at this slide, and you have to look at which variable comes first. X is first horizontal, y is vertical.
Oh, okay.
All right, any other questions on the first guy? My drawing skills are pretty good on that one. Pat myself on the back. Okay, not in standard form. We're not going to freak out about it. We know it has to equal 1. We've got to do a little bit of manipulation, not a lot. I'm going to subtract 9 off to start with. And then, of course, I want to set it equal to 1. I'm going to divide by negative 9. Okay, so I'm already like questioning the order on some of this here a little bit, but let's see where we're at. I don't like that we have this negative 9 on the bottom of our first denominator. So I'm thinking about if I kick the negative out front. I don't like that at all. 2 negatives make a positive. For dramatic emphasis, we're over 1. I don't like the order of that. Because remember, hyperbola, the standard form, the minus is in the middle. So I'm just going to flip-flop them. And that's important because y squared should be coming first. Minus, not equal, minus. So now I'm in my standard form. So a little bit of manipulation, subtraction should always be in the middle. It's important. Y is first, so now this one's going to open vertical, up and down. Yeah. Okay, so I'm going to start marking it out just like we did the last one, just like you start an ellipse. 1 is under y. Square root of 1, 1, under y, up and down 1, from your center of 0, 0. 9 under x, square root of 9 is 3, under x, left and right 3. If that was an ellipse, we draw our oval and wrap it up, right? But we got to draw our central box for our very lovely hyperbola. Once you have the central box, you can draw your asymptotes from the center to each corner. Okay. And we said this one's going to open vertically. This one's going to be pretty wide because I'm looking at those asymptotes, which is whatever. So this time I'm going to take the top point on the box. I'm going to start at the top. So 0, 1. And of course I'm going to draw close to my asymptotes. I'm not going to cross or touch. I'm going to take the bottom point on our central box. Now again, I don't expect you to draw this, but just for dramatic emphasis to highlight it, the transverse axis is the one that always connects the vertices. So this time my transverse axis is vertical. So that is a whopping 2 units long. Get it? Now, we have to do the foci yet. Okay, all right. And of course the asymptotes, that's going to be easy. Foci, my c² equation. And of course it's minus, so I know my foci equation goes to plus. So I'm going to do 1 plus 9 for 10. And we're going to square root that. Now, for me to mark that on the graph, you can see I got a cheat because I forgot what the square root of 10 is. I punched it in earlier. It's about 3.2, give or take. And that has to be inside, of course, the hyperbolas, the blue. So I'm going to go down 3.2, good enough, up 3.2. I'm just going to estimate it. But when I list them over here, I'm going to use exact ordered pairs. So my foci is 0 square root of 10, 0 negative square root of 10. Should have put a longer blank. I'm just going to put plus or minus. Asymptotes, of course, mx plus b form we're using. You have 2 of them, one that rises, one that falls, so a positive and a negative slope. And I'm just going to count rise over run. Doesn't matter from the center to which corner you count. I don't know why, I just always do the top right one. I'm going to go up 1 over 3. Yeah. That's as wild as hyperbolas get. Any questions on that? I'd rather draw this than the ellipse just because my oval drawing skills is rough. Okay. All right. And of course, we got to write some equations. You know the drill. So again, and I saw in some of your quizzes too, the same thing. Sometimes I make myself a little sketch, okay, even though there's not a graph grid here. Find the equation. That was like very dramatic little ding, 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 ding. Okay, find the equation of the hyperbola. Vertices plus or minus 3, 0. So that would be 3, negative 3. So if it's on the x-axis, I know it's going to open this way. So I like a picture. Well, if I could draw better, obviously. So that's clutch because that tells me that the x variable needs to come first since it's horizontal. Okay. Oh boy. Now, we also know, of course, what A is. What's A? How many units is A?
Come on, you got it.
From the center, you went right 3, left 3, so A is 3. But when I throw it in my equation, I'm going to put the squared form, 3 squared, 9. Now the problem is the B squared. That's always the problem, I feel like. So they do give you the foci. So let's say that's 4, 0, negative 4, 0. So if you know the foci, you know what C is. What's C? How many units? C is? Don't everybody yell it? 4. Okay, so I'm going to use my c squared equation. Of course, it's the plus form when we're in our hyperbolas. 4 squared. We already know a squared was 9. And you can do a little mental math there. What's b squared? 7. So I'm just going to pop 7 in here. Call it good. Okay, and I have kind of a random question for you, and I kind of always go back and forth on this. So obviously we're not having your test next week with testing. It's going to be the following week. Like on these style of questions, do you want a graph grid provided at all on them? Do some of you like that?
Yes.
Yes, some yeses. Okay, so maybe I'll just throw some graph grids on there and be like, use it, don't use it, whatever. I'll just put a note, you know, there's nothing required to do with it. But sometimes I like a little graph grid. Okay, Find the equation in foci. Here we got a graph grid. And they want us to graph it, clearly. With the vertices at 0, 2, 0, negative 2. I'm going to start with that. And your asymptotes. Interesting. Now, that is important, the asymptotes. But first, knowing that my vertices are at 0, 2, and 0, negative 2. This open horizontally or vertically? Vertically. So I know y squareds comes first. So I can kind of set it up a little bit. Now, I also have some other fun-filled information. Remember, of course, our center is at 0, 0. And we know our asymptote equation. I'm going to mark those in green. For dramatic emphasis, our slope would be over 1, of course. So we'd go up 2 over 1. Up 2 over 1. Yes, I know there's 2 of them. I'm just going to start with that guy, though. Because I pretty much can fill in this equation right now. Because your rise is 2. Your run is 1. So A is 2. And when I throw it in my equation, of course, I'm going to throw in the squared form. I'm going to finish drawing that a little better in a minute. And of course, what's B? What's your run? 1. 1 squared. I don't know if it's worth adding the over 1 there, but I'm going to put it there. Okay, so let's finish drawing this so it looks a little better here. So I'm actually going to finish off my central box here. We're going 1. I'm going to draw the other asymptote. I feel like I have a lot of dashed lines happening there. Okay, and of course it would open vertical. And for whatever it's worth, which is probably a whole lot of nothing on this, remember, in your graphing calculator under apps and conics, hyperbolas are in there also. Again, it's not that helpful because it's not going to give you foci or your asymptotes, equations, or any of that shenanigans, but it does give you whatever sort of a picture if that's helpful at all whatsoever. Any questions on this one? Elliot?
Do we need to find the foci?
Yeah, I'm going to list those next.
Oh.
Are we good with our graph? Okay, so let's do our c squared equation, of course. It's going to be the plus form. We can mental math it. 4 plus 1, right? 5. So square root of 5. Now, I'm going to mark them. It doesn't say you have to graph them. I'm going to mark them. I punched in square root of 5 earlier. It's about 2.2 for the reference there. Oh, man. 2.2, man. That's clearly not 2.2, but whatever. And then I'm going to list my ordered pairs. We went up up the square root of 5 and down. So there's my foci. Any questions on the equation? All right, save the best 2 for the last 2. Okay, vertices, 0, 6 passes, whoa, negative 5, 9. That's helpful. Not really. Okay, so right away, if I'm thinking about a picture, vertices 0, 6, 0, negative 6. Okay, so that gives me a little something, something. It tells you it's going to open how? Vertically or horizontally? Vertically. So I know I'm on my y squared equation. So I got that going. And I also can tell you A. 6. From the center to that, we cover 6 units. So A is 6. A squared. As always, the little problema is we don't know this. And I'm like, man, they didn't even give me the foci. I know it's rude. Hardcore rude. They gave me this point. Well, okay, I guess I probably should do something with that point. Well, what do we know about ordered pairs? X, Y. So I'm like, all right, let's see what happens. I'm going to plug negative 5 in here for X, and I'm going to put in 9 for Y and see what we have. So I'm going to have 9 squared over minus negative 5 squared over B squared. And I'm like, oh, I can work with that because my only variable in there is b squared, which I need. So I'm just going to now algebraically go through and try to solve for b squared. 81, 36, 25, b squared. We all hate fractions, probably except for me. I would clear your denominators. Now your denominators are 36 and b squared. So I'm going to times everything by a 36b squared. So when I distribute that to my first fraction, the 36 are going to cancel, so I'm going to have 81b squared left. The middle, the b squareds would cancel. I got to look what 36 times 25 was. 900. Yeah. And then 36b squared times 1. Now it looks crazy, and don't be like, oh my gosh, we got a factor like this. No, no, no. We're solving for b squared. I don't care what the actual b is. I need b squared for my equation. So I'm going to get them on the same side. I'm going to subtract 81b squared over. So I have negative 900, negative 45b squared. Bingo, bango, I can get b squared alone super fast in my calculator. I'm going to divide off negative 45. And b squared is 20. Put it in your equation, circle it up. Power of the smart board, I'm just going to erase b squared and put in a 20.
This is a question I was asking. You have to show work. Because I just guessed and checked until I found it.
Guessed and checked. Yes, you got to show work.
Dang it.
All right, questions on that one? Because we're going to kick it up a notch on b, right small. That's what I'm going to tell you for the last one. Okay, both sides. Okay, so kind of similar. Let's just first kind of think about our foci. Square root of 10. Well, I don't care the exact answer. Square root of 10, comma 0. Which axis are those points on? The x or the y? X. So I'm just ballparking. That's clearly not accurate. So we know we have the x squared equation. Now, some of you, keep it together over here. Some of you can mentally picture that. You don't need to draw the picture, whatever. X squared, okay. And then I'm looking at this and I'm like, I'm sighing. Because do you know A? Do you know the distance from the center to the vertex?
No.
Nope. Do you know C?
Yeah.
We have C. That's something, that square root of 10. Okay, but that is.
Is there no answer?
No, there is. Just wait for it. It's going to turn into a system of equations. And we have that random point. Okay, so let's start with our, what we know, the easy part. Let's start with our c squared equation. Now, the only thing I have for that, what's c? Square root of 10. If I put the square root of 10 in there and square it, we get 10. Okay, so I'm just going to kind of label, that's where what I got now, my first equation of knowledge. Now, my second equation, oh boy. Okay, here we go. Let's label it number 2. That seems appropriate. So I'm going to plug the points in like I did the last one. So I mean, easy enough, 4 squared, let's just go to 16. Okay, can you square 3 square roots of 2 in your head? Can you square 3 square 18? And again, do we know a squared or b squared? Now, as much as you'd like to write no solution on this, no such luck. I'm going to scroll it up just a little bit here. So first off, you can see I've got them numbered. We do kind of have a system of equations. So I'm thinking, oh my gosh, am I using substitution or elimination? I don't know. I'm not going to tackle that yet. Before I decide that, we probably would want to clear those fractions out because it's kind of gross looking with that. So I'm going to multiply by a squared, b squared, the denominators. So let's take a look. The a squareds would cancel here, so I'm going to have 16b squared. B squareds then would cancel, so 18a squared. And a squared, b squared times 1. Okay.
This is ugly.
It is. It sure is. Now, I probably would lay off elimination just with the squares. It might make it tricky. I'm going to use substitution. So, clearly I think this blue equation looks easier to start with. I'm going to solve it for either a squared or b squared and substitute it in here. I'm going to, just to keep us on the same thing, I solved it for a squared because I was like, okay, I can subtract b squared off. Super easy. So I'm like, okay, 10 minus b squared. And I'm going to substitute this in for my a squared. Oh, both of them. Fun. So fun. So it's like a puzzle. Okay. Oh, a squared, let's put in our 10 minus b squared. A squared again, I'm putting in my 10 minus b squared. I'm going to scroll it up again while you guys continue to cringe. Okay, what's your next gut instinct tell you to do?
We're gonna have to factor this.
We might.
Oh, of course.
I would distribute, you know it. So we have a lot of variables. I believe it was Avery that asked if we're going to have to factor on this. Good, solid chance. So right now I'm thinking, okay, let's set it equal to what? 0. And I'm going to put it in the correct order, meaning highest exponent to the lowest. So I want b to the 4th first. So I'm going to add b to the 4th over. So I got rid of that. I'm just going to put I added it. I'm going to subtract 10b squared off. And we're going to combine all of these b squareds. 16 plus 18 minus 10. How many b squareds do you have? 24. And we still have our minus 180. Now, this does factor. I know we're shocked by that. I'm just for the sake of time, and we're at the end of our ropes with this. The numbers that work are 30 and negative 6. Notice I didn't fill in the variable. I'm not just going to put b, I'm going to put b squared. Okay? Now don't get crazy and go all the way to solve for b. I mean, you can, but that's extra work. Remember in our equation, I need it in the squared form. So I'm going to solve for b squared. Oh, I don't like that. So you have two potential answers for b squared. Which one is an issue? The negative. Because if it did root it, it'd be imaginary. We can't use it. So now I'm going to scroll it back up. And I'm going to put in my equation the b squared is 6. Okay. So we're getting somewhere, maybe, sort of. So remember, b squared. And you know what? I can do a squared in my head. Yeah, substitute it in. If b squared is 6, just back substitute it in. 10 minus 6, 4. Woo! Love it. Think of all those good math skills we got to use. We got to distribute, we got to factor again, we got to clear fractions and solve rational equations, use substitution. I should get an award just for this problem and all the math skills we got to use. Okay? Questions on that one? Looks on your faces is priceless. Love you guys. Okay. All right.